Hello viewers, today we are going to be discussing valency. And in order to understand how to calculate and what is valency, let us start by defining valency. Now valency is defined as the combining power of an element. And every element has a combining power, which is the valency. For instance, if we have an oxygen atom, just one oxygen atom, an oxygen atom has an atomic number of what? 8. Meaning that he has how many protons? Plus 8 protons. And what? Electrons of minus 8. Now the net charge of an oxygen atom will be equal to 0. That is, plus 8 minus 8 will be equal to 0. But when calculating valency, we know that when an oxygen atom is about to combine, it combines as a gas, and it always has 2 minus or negative 2 at the top. Sorry, it comes 2 minus. What is this 2 minus? This 2 minus is the valency. And how do we calculate this 2 minus to get this 2 minus? It's still the same calculation, but in this case we are no longer going to be calculating net charge but valency. Now how do we do that? First of all, we are still going to be needing our proton number and our electron number. When oxygen is about to combine, let's draw the structural formula for oxygen. Now it has 1, 2, 3, 4, 5, 6, 7, and 8. Now oxygen needs 2 electrons to complete its octet state. Now let's imagine magnesium, for instance. Magnesium, which has 2 plus, gives oxygen the remaining electron it needs. Therefore, if you calculate the number of electrons in oxygen, we will have it to be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Therefore, now the electron in oxygen will be negative 10. Negative 10. Because magnesium has given it its electrons, right? Now the valency of oxygen will be equal to plus 8 minus 10 will be equals to minus 2. And that is how we got this 2 minus for your valency of oxygen. Now for the valency of non-metals, usually non-metals, to understand how to calculate for non-metals and for metals, non-metals usually have 5, 6, 7 electrons in their outermost shell, which is the last shell which you have electrons. Now all of them are heading to 8. They want to complete 8. But for metals, now this is non-metals. For metals, they usually have 1, 2, or 3, or 4 electrons, and is also heading to 8. But for metals, the case of valency is a little bit different. How? If we have a lithium ion, for example, a lithium atom, for example, a lithium atom has an atomic number of 3, right? And which means it will have what? A proton number of what? Plus 3, and an electron number of equal to what? Negative 3, right? But since we are calculating valency, we don't need to calculate net charge. Let's draw the lithium structure. 1, 2, and the remaining 1. Now I need 7 to complete, but it is very hard for it to get this 7, and it's more easier for it to lose this one and go back and complete its octet state in this K shell. Now remember, this is the K shell, this is the L shell. Now it can lose the electron in this L shell, which is just 1, instead of looking for 7 electrons to complete. Now when it loses this 1 electron, the electron number here will now be what? 2. It has lost its electron when combining. Remaining 2 electrons. Now which will be what? -2. If we are to calculate the valency at this point for lithium atom, it will be what? +3 minus 2, which will be what? +1. And that is why you have the valency of lithium to be Li plus, which is, this plus means +1, which is the valency. Thank you for watching.